All right, we're bringing a lot together in this chapter. So some tips. We're going to think about the relationship between forces and torques. Okay? Don't forget that if I add up all of my torques, I get a response. This is the angular acceleration. Okay? Now, how do I get a torque? Okay? Don't forget that a torque is related to a force. So it's a force at a distance. So it's R cross F. So it's a vector. Okay? So R cross F, this is the displacement from the axis of rotation to my force. So for instance, if I have right here, if I have an axis here, okay, and I'm going to apply, let's pretend like I just had a rod here, okay, I had a rod, and I have a force that's doing this. So this is my applied force, okay. If I want to draw R, I draw it from the axis to where the force is applied, that's R, and that's my force, okay. Now, the magnitude of the torque is related to is going to be given by the perpendicular component of the force. Okay, so there's some angle theta here. The direction is determined by the right-hand rule. And if the force exerts a torque, I add up all those torques and I get a response. The response is the angular acceleration, how the angular velocity is changing. Now, we have to measure our moment of inertia from the same rotation axis. So in these problems, pick an intuitive rotation axis. Usually there is one. If there's not, we can figure out how, what's a good place to measure from. But in principle, it doesn't matter as long as you're consistent. You say, that's the axis. I'm going to measure everything about that axis. Okay? Once you calculate all the net torques, you calculate a response. The response is alpha, right? Alpha given by the right-hand rule. And once you find your alpha, then you can use our new kinematics equations. Okay? So, the final key point here is that in certain cases, we can connect the translational quantities and the rotational ones. Make sure you do examples 714 and 716 because they're really good. And it can be really challenging to put all of this stuff together because you got to keep a lot of stuff in your head. Torques, moments of inertia, angular acceleration, kinematics. And now we have a connection between rotational and translational quantities. So, I encourage you to find a good space to work in here. Okay? Put your distractions away because you're going to have to keep a lot of information in your head at the same time. It's good training, if nothing else. Okay? So craft your environment, find a nice quiet place to do this. Put all the information up at the same time if you need to, and get used to using it all at the same time.